Okay, guys. So read the board carefully. Okay, it says get on your computer and log in. You'll go to extramath.com at the top of the screen, and you'll follow this when you get there. Click sign in. You do not click sign in with Google. That'll link you to Miss O'Brien. Okay? I will not have access to that. Once you get to that point, get out your RTI schedule from yesterday. It has like your RTI groups and stuff on it. At the bottom, you were supposed to write in your extra math information. Okay? On that little piece of paper that I gave you yesterday, it had probably your first name, space, your last initial. Under where it says sign in with Google, it'll ask for a parent or teacher email. You will have to type in my email, which is written here, okay? And then where it says first name, you will not enter your first name. You will enter whatever was on your little piece of paper, okay? Whatever you wrote on the bottom of your RTI form. Like Sophie said Sophie B, and there was a space, okay? All of yours probably should have a space. And then your PIN number. Once you type in your PIN number, check the Remember Me box, and then you shouldn't have to type in my email ever again, okay? Once you get logged in, I do want you to just go through it one time. You can turn down the volume. You don't have to listen to the directions because you've done it before. And you will all start with addition. It would not let me bump you past that. So you should all have addition today. So just work through it once. Once you get through it, just close your Chromebook and sit quietly, okay? If you're at home, pause this until you get your extra math done. Just get through the addition and then restart the video and we'll go into today's notes. Okay, so we have a test over Chapter 2 next Wednesday. The first half of Chapter 2 was over exponents, powers of 10, mental math. Okay, we had the 2.1 to 2.5 quiz. The next few sections were over just multiplication, okay, 2 by 1, 3 by 1, 2 by 2, 3 by 3, algorithm, lattice, the stuff that our second quiz was over, the multiplication quiz 1, which I still have for you. I'm waiting for one more to be submitted, and then I will give those back to you probably tomorrow, okay? All we have left to do is 2.8, which is on estimating, and then we're going to spend a couple days focusing specifically on word problems, okay? On Monday, you will have a review sheet. Tuesday, we will go over it. On Wednesday, you will have your Chapter 2 test, okay? So, who can tell me, Carter, do you have this piece of paper? Oh, did I just give you the wrong one too? Where'd you put this? I gave you guys all a homework page? Okay, hold on. Let me get the right one. Okay, now that you guys all have the right paper. Pull this one to the top, the one that says 2.8 notes and notes estimate products. First, what does it mean to estimate? Carter, put that away. All you need on your desk is the notes page and a pencil. Callan, what does it mean to estimate? It's not round, okay? We do round to find an estimate, but it's not the same thing as rounding. Okay, but we use rounding to estimate. I agree with that. Briley? Yeah, we're giving kind of an answer close to the actual. Okay, I call it a ballpark answer, which means it's close, but it's not an accurate answer. Okay, it's not an actual answer. Estimating should be mental math. Everybody say that. Estimating should be mental math. Meaning, if you're doing your homework tonight and you are doing an estimate and you're having to use lattice or algorithm, you're doing it wrong. Okay? On estimating, you should not have to scratch work out to the side. You should turn the problems all into mental math problems. Okay? So, the first vocab word up here says compatible numbers. What does the word compatible mean? Sometimes when I make groups, my groups are not compatible. Sometimes when I make groups, my groups are very compatible. What does that mean, Chase?
Compatible means they go together.
Yeah, they kind of work well together. They go together nicely, okay? Compatible numbers, we're just going to write numbers that work well together. Compatible numbers are more important, and we're going to talk about them more when we're estimating division. Okay, but compatible numbers are numbers that work well together. Numbers that work well together. Now, thinking about multiplication, what are the easiest kind of numbers to multiply? Logan? Okay, single digit by single digit, right? I agree. What else? Cam? Anything times 0 is 0. Okay. What about larger numbers? Emmett?
What that only have like digit is 0?
Yeah, numbers that have a lot of zeros in them, like a one-digit number with zeros behind it. Those are what we want all of these problems to look like when we are estimating, okay? We are turning all of these problems into a mental math problem. So if you look at it and you cannot solve it mentally, you did it wrong, okay? Now, students don't like estimating because there's not necessarily one correct answer. There are multiple correct answers, but there are also some wrong answers. Okay, so we're just going to jump into examples. I'm pulling these examples from the book. You don't have to get your book out. But on page 125, the first example tells me to do 92 times 12. So I want you to write this right here. 92 times 12. Now, to estimate, we round the problem to make it a mental math problem. You can round one of the numbers or both of the numbers. Depending on your ability to to do your facts, how well you know your multiplication facts up to 12 times 12, you may round it different than the person next to you, and you may both be correct, okay? So when we're rounding, we can change one number or both numbers. Which way do you think it would give us the more accurate estimate? Lena?
Like 90 times 10.
So the question was if we change one number or both numbers, which one would give us the more accurate estimate? If we change just one or if we change both?
Change just one.
Yeah, if we change just one number, our estimate should be closer to the actual value, and that's our goal, is to get as close to the actual as possible in an easy way. Okay? So for this one problem, we're actually going to round it 3 different times and show you that all of those answers are okay estimates. So let's start by leaving where we're rounding 1. Let's leave the first number the same, 92. What could we change 12 to make this a mental math problem? Avery? 10. So I only changed one number. What is 92 times 10, Cam? 920, because 92 times 1 is 92, and we add the 0. Okay, everybody in here can do that mental math problem. If I leave the other one the same, This is one that some of you, if you don't know your multiplication facts, your 12s very well, you probably wouldn't choose to round it the other way. What could I round 92 to make this a mental math problem? Ethan? 90. What fact would you need to know to be able to do this mentally, Ethan? 9 times 12. So if you don't know 9 times 12 very quickly, would you choose this way to round this problem? No. The top way works also, okay? So this is where, depending on how well you know your facts, you may round it different than the person next to you, but you could both be correct. Okay, what is 9 times 12? Cooper? 108. So is my answer 108?
No.
What is it? Kanan?
1080.
1080, because 9 times 12 is 108, and then I add my 0. Okay? So both of those are good estimates. Okay, because we just changed one of the numbers. But you could also change both numbers to get an estimate. And I give you some more guidelines kind of down here under this box. But usually if it's a single-digit number, you leave it alone. If it's a 2-digit number, you round it to the nearest 10. If it's a 3-digit number, you round it to the nearest 100. So 92 and 12 are both 2-digit numbers. So who can round both of those to the nearest 10? Kinley, what would I have? 90 times 10 would be an estimate if I am rounding both numbers. Sam, what is 9 times 1? 9. And then how many zeros do I need behind that? 2 of them. Now, all 3 of those estimates are good estimates. Which one do you think is the better of the 2? Kanan, what do you think?
940.
Okay, then 920. Why do you think that?
Because you want 900 on rounding both, and they're both very close.
Okay, and let's think about how much we changed the numbers. In this one, we dropped 12 by how many?
2.
By 2, so we changed it by 2, but there were 92 sets of that. In this one, how much did I drop it by? 2, but there were only 12 sets of 2 on that one. And this one I dropped by 2 and 2, okay? So let's talk real quick if we think these are going to be high estimates, which means they're above the actual, or if they're low estimates, which means they're below the actual. Who thinks they know if these two are going to be high estimates or low estimates, and why? Reese?
High?
You think they're going to be higher than the actual answer?
Wait, no, lower.
Lower, why?
Because two-digit by two-digit numbers, and two-digit by two-digit numbers are usually big.
Okay. What do you think, Jack?
Because we rounded down.
Yeah, we rounded our numbers down, which would make our answer go down. So let's go ahead and guess that these are a low estimate. What about 90 and 10? Did we round up or did we round down?
Down.
We rounded down, so that means our answer should be lower than the actual. You can put an X right there because we actually rounded it 2 ways in the first box. We could have put one of those over there. Okay? Compatible numbers are just numbers that go well together. 92 and 10 go well together because we can solve them mentally. So now the actual answer on your homework tonight, there are 4 problems where you have to write out your estimation problem. So this is the problem. You would write out your estimation problem and the answer, but then out to the side you will do the work to find the actual answer. Okay? For today, for notes, to save time, I'm cheating and using a calculator. 92 times 12 is 1,104. Were we correct when we said that if we round one number, we're closer to the actual than if we round both numbers. Yes, but again, all three of those are okay answers. Okay? The best answer is this one. Okay, that one is the closest, but if you don't know your multiples of 9 up to 12, would you choose that way to round it? No. Okay, but again, they're all fine answers. Okay, let's move on down the page. So I gave you kind of some guidelines here. When you're rounding, if you have a single digit number, if one of your factors is a single digit number, try and leave it alone. Okay, if it's a single digit number, try and leave it be and just round the other one. If it's a 2-digit number, you try and round to the nearest 10. If it's a 3-digit number, you try and round it to the nearest 100. So on number 9, we're going to try it. We're going to try and come up with 2 different problems. Let's try and round one number 2 different ways. So who thinks they can give me a estimated problem that I could use to find the estimated product of 106 and 52? Paxton, what would you round 106 to? You want it to be mental math. Do you know your multiples of 105? Stella?
110.
Okay, Stella's saying 110. Raise your hand if you were thinking something different. Okay, what were you thinking, Ethan? 100. We're going to write both of those. Everybody write down 110 and 100. If I was rounding 110 to the nearest 10, I would round it to 110. If I'm rounding it to the nearest 100, I would round it to 100. What would I need to change the other number to be able to do mental math times 110, Ethan? 50. Most of us know what 11 times 5 is. What is 11 times 5, Ethan? 55. And then how many zeros do I need behind it? 2. Okay, so on that one, I did have to change both numbers to make it mental math. Let's look at the other one. If we change this one to 100, if we can leave the other one alone, we want to. Can we leave a 52 as 52?
Yeah.
Yeah, because if I'm multiplying it by 100, can I do that mentally? Yeah, so we're going to leave the other one as 52. And we would get 5,200. Who thinks they know another way that would probably be an acceptable way to round this? Paxton?
60 times 100?
I'd say 60 would be too high. If we rounded 52, we would have to round it to 50. Kinley?
100 times 50.
Yeah, 100 times 50. But again, the other two are better estimates. But if you did 100 times 50, let's go ahead and write it. That's an okay estimate, but if you can do one of the other ones, they are better estimates. Okay, so for estimate, I'm just going to write up here. I'm going to show that it's up there. The actual 106 times 52, 5,512. Were we correct that the top two were the closer estimates? Yes. Okay. Even on the first one, even though I changed 2 numbers, I didn't change either one of them very much. Okay. So it's a closer estimate than the bottom one. Number 11. Notice there's a single-digit number. So we want to try and leave the single-digit number a single-digit number. So let's leave that be. Now this is where, depending on how good you are at your math facts, you may round this one differently. Looking at 127, Addie, what do you think you could round it to?
120.
Okay, 120. What fact, Addie, would you need to know to be able to do that mentally? What mental math fact would you need to know? Yeah, 12 times 8. Jalen, what is 12 times 8? And see, this is one I guarantee this is one a lot of you had to write down yesterday, right? Chase?
96.
96. And then how many zeros would I need behind that, Chase? 1. Now, if you don't know your multiples of 12 up to 8, would you want to choose that method? No. So let's write it a different way. Let's leave the first number the same. What would I have to do to that second number to make it mental math, Avery? Times 10. And then 127 times 1 is 127, and I'd add my 0. Does anybody know another way? If you can do it mentally, this is where we're getting up there in the ifs. Callan? 130 times 8. But what would you need to know mentally to be able to do that one? Kinley? 13 times 8. Does anybody know 13 times 8? Chase? 104. Do you guys agree? 104? Okay, but again, if you're going to choose that, you should be able to do it mentally. You shouldn't have to do scratch work out to the side. Okay, so if you know 13 times 8 is 104, then that's a perfectly good way to do it. If you do not know that, I would stick to the 12 times 8 or even the 127 times 10. Okay, the actual, let's check and compare it. 127 times 8, 1016. So our estimates are up here. 1016. Why is our 130 times 8 over the actual? Why is it higher than our actual, Jack?
Because we rounded 127 up to 130.
Yeah, we rounded 127 up and we kept the 8 the same. On 120 times 8, we rounded 120 down. So that's why our estimate is under the actual. Okay, go ahead and flip your paper to the back. And open your book to page 128 quickly and quietly. We are actually going to skip number 15 due to time. So I want you to read through number 16. When you get your book open, read through number 16. When you read through number 16, on your paper, I want you to write ACT colon, and under it write EST colon. What do you think those stand for, Nolan?
Actual estimate.
Yeah, actual and estimate. Anytime you're working in here, you will always have to tell me your actual problem for that word problem and then your estimated problem before you give me an answer. So reading through number 16, who thinks they know the actual math problem that it's asking for? Stella?
225 times 10.
Does it say times 10?
Oh, 18.
Times 18. So 225 times 18 is the math problem. But what in that problem tells me that I don't have to find the actual, that I can find the estimate? There's one giant word. Avery? about. When you guys see the word about in a word problem, especially a multiplication problem, you should be excited because that makes your life a lot easier. That means you can estimate. So always write the original problem, but then tell me what your estimated problem is. So let's change this to a mental math problem. Who thinks they have one that is a good one? Callan? 10 is too far away because 18 is closest to what? 20. Let's go ahead and change that to 20 first. And now let's get a number that's as close to 225 as we can get, that we can mentally multiply by 2. Emmett?
225 times.
Let's not do 225. Stella?
220 times 20.
Can we do 220 times 20 mentally?
Yeah.
Could we do 230 times 20 mentally?
Yes.
Yeah, both of those would be good estimates. We'll go ahead. She said 220, so let's do 220. What is 22 times 2? 44. How many zeros do I need? 2. And if this was a word problem, I should put whatever the question is, but it would be about $440. I can't, what was it talking about? The price of a cabin?
Yeah.
Okay. Now, we did not get through many of the notes. Shh. Hey guys, quiet, just a few more minutes. We only got through one of the word problems. For your homework, you already have the work page. Everybody pull that work page out and look at it. There are only 8 problems. You're doing the My Homework page on page 129 and 130. On 1, 2, 3, and 4, look at your work page. What do you have to do for 1, 2, 3, and 4, Kinley?
You have to estimate and find the actual.
Yeah, you're going to show me your estimated problem and your actual problem and answer. Okay? On 5, 6, 7, 8, do you have to find the actual? No, you just have to do whatever it tells you to do in the book. Does that make sense? Jack? Nope, you do not have to finish the notes page. Okay? Questions on what your homework is? You should not have anything written in the book tomorrow. It will all be on your work page. Okay? I suggest you put that somewhere where it will not disappear. And I will see you guys tomorrow. You may go.